Assalamualaikum and hi. My name is Sofia Najwa binti Shamsuddin, and today I'm going to present to you about integration by use substitution. Integration by use substitution, also known as use substitution or the reverse chain rule, is a method for finding an integral that works only when certain conditions are met. This means that the provided integral has the following form, which is integral f gx g prime x dx is equal to fu du. Here, first integrate the function with respect to the substituted value, which is fu, and finish the process by substituting the original function gx. Integration by substitution is the opposite of the chain rule for differentiation and can be thought of as reverse application of the chain rule. Before we can comprehend the concept of integration by substitution, we must first grasp what integration is. The integral of a function f(x) is denoted by fx and is given by integral fx ds equal to fx plus c, where fx is called antiderivative or primitive, fx is called the integrand, dx is called the integrating agent, c is called constant of integration or arbitrary constant, and x is the variable of integration. Some integrals could not be evaluated directly by using the basic integration formula. In this case, we can use integration by substitution. The idea is to choose a suitable substitution so that the integration would be much simpler to evaluate. When we make a substitution for a function whose derivative is also present in the integrand, the method of integration by substitution is particularly useful. As a result, the function becomes simpler and the basic integration formulas can be employed to integrate the function. The integration rules are defined for different types of functions. There are three integration rules that we are going to demonstrate in this video with the example. First is power rule. Power rule is used when u is equal to the function in the bracket. Second is logarithmic rule. Logarithmic rule is used when u is the denominator. And lastly is trigonometric rule. Trigonometric rule is used when u is the angle, if only the trigonometric function is existed in the table of integrals. We are already familiar with the antiderivative of basic functions. It is simple to calculate the integrals of these functions. However, this method of integration is confined to simple functions. For determining the integrals of more complex functions, other methods of integration must be employed. Next, my group members will present some of the example questions that are based on power rule, logarithmic rule, and trigonometric rule.
Assalamualaikum warahmatullahi wabarakatuh. My name is Sofia Shakira binti Malazim. Now I will continue with integration by use substitution of power rule. This is the question. First, we will find which one will be the u. So let u equals to x power of 3 minus 2. Differentiate it, it will be du over dx equal to 3x squared and dx equal to du over 3x squared. Next, we will replace x power of 3 minus 2 with u. Then we can cut both 3x power of 2 and it will be left with square root u du. Then square root u we will change to u power of 1 over 2 du. And then we will integrate u power of 1 over 2. It will be 2 over 3 u power of 3 over 2 plus c. Then the answer would be 2 over 3. We will change back u with x power of 3 minus 2 and the answer would be 2 over 3 x power of 3 minus 2 power of 3 over 2 plus c.
Assalamualaikum warahmatullahi wabarakatuh. My name is Hudaida and I will present about question number 2, logarithmic rule. Okay, that is the question and the solution is we have to define what is u and what is du. First of all, we take for u x power of 3 plus 3x, and then I forgot to put the du per dx, but I will explain. Du per dx equal to 3x power of 2 and a plus 3, and then we will transfer dx into the 3 power of 2 plus 3, and then it's defined as du. Then we simplify and we get 3 bracket x power of 2 plus 1 dx. Okay, next. After that, after we know what is u and du, we will simplify again until it get 1 per 3 du equal x power of 2 plus 1 dx. Next, we will write down again the question, and then is equal to, we will simplify the question. It will be integrate 1 per x power of 3 plus 3x, and the x power of 2 plus 1 we will replace with the 1, and we will take the x power of 2 into beside the 1 over 3 power of x power of 3 plus 3x, and of course we will put the dx. Next, we will replace the x power of 3 plus 3x with u, and then dx with du. Okay, I'm sorry, we will replace the dx with 1 per 3 du. Okay, next we will put the 1 per 3 into the front, and then it will remain the integrate 1 per u du. And then we look at the hot tips that I put. Integrate 1 per x dx equal to ln x plus c. So because we use u, then so it will become u. So ln we will replace it. You will replace because we follow the hot tips. Okay, we replace ln u plus c. We replace the integrate to, that integrate to become ln u plus c. So the final answer is 1 per 3 ln, and that u we will replace the value that we got earlier. So it will be the final answer 1 per 3 ln x power of 3 plus 3x plus c. We cannot forget the plus c. Okay, that's all.
Assalamualaikum and hi, my name is Asmira Shwada binti Muhammad Suhaimi. So the next question is integrate the x over 1 plus x power of 4 dx. How to solve this? From this question, we can see it is trigonometric rule. So the first step is we can factorize the x power of 4 to x squared in bracket power of 2. We also can identify the value of u, du and dx. So the value of u is x squared, which is from the factorization. Meanwhile, du is 2x dx, which is come from the differentiation of x squared, and dx is du over 2x. To solve this question, we can write integrate of x over 1 plus u squared du over 2x. Then we also can eliminate the x value, and the number of 2 has to put into the left hand side, and it will be 1 over 2 integration of 1 over 1 plus u squared. The next part is we need to refer the formula of 1 over 1 plus u squared, and it will become 1 over 2 inverse of tan u. So the last part is we substitute the value of u, which is x squared, and plus with the c. So the answer is 1 over 2 x squared inverse tan plus c. So that's all the solution from this question. Thank you.
Also will present the conclusion. In a nutshell, it is possible to think about integration by substitution as the reverse chain rule. We must be well versed in derivatives until we know which integration can be used for substitution. For U substitution, we may try to employ integration by substitution anytime we see a function time its derivative. We can integrate composite functionalities with its existence. It also helps in managing with existing problems. And the last, the inner function becomes the variable in U substitution, which allow us to take a complex expression and make it simpler. Okay, that's all. This is the references that we take for this project. This is the second references. Okay, I think that's all from us. Thank you.